Hi all, I am a faculty of Department of ECE Swati. I am going to present a small topic under telecommunication switching network. So it is a very important topic in this subject. So I was handling this subject last semester. So I would like to share this topic. So the topic here is synchronous optical networks, otherwise called as Sonet. So here we are going to see about Sonet, and also we are going to see what is the introduction to Sonet, some of the Sonet layers, architecture, frames, strings and all those things. Okay, so it covers maximum all the details about Sonet. So another thing I want to tell here is Sonet is a synchronous optical network that is similar to uh, SDH. So SDH is nothing but a synchronous digital hierarchy. So both the Sonet and synchronous digital hierarchy, both are some of the standard protocols that is used for communication. So we will go for an introduction, what is Sonet, and introduction to Sonet. Okay, so Sonet, it is nothing but, as I told in a previous slide, synchronous optical network and synchronous digital hierarchy. So Sonet is a synchronous optical network. It is similar to synchronous digital hierarchy, but is standardized protocols. So this both Sonet and SDH now is used for transferring multiple digital bit streams synchronously. So it transfers the data or signals synchronously over optical fibers using lasers or highly coherent light from light emitting diodes. Okay, so at low transmission rates, data can also be transferred via an electrical interface. Okay, next, the method was developed to replace this. So this before the Sonet and SDH, there was another method called PDH. It was developed, this Sonet and SDH was developed to replace this PDH, which also known as fully synchronous digital hierarchy system, for transporting large amount of telephone calls and data traffic over the same fiber without synchronization problems. So by the use of this PDH, there was a lot of synchronization problems. So to overcome the disadvantages of this PDH, Sonet and SDH was identified or was developed. So we'll see how this Sonet was originally designed for a public telephone network. So it was independently developed in USA and Europe for synchronous transmission of signals. So this Sonet network, it uses a TDM multiplexing, so which means a time division multiplexing, which divides the time synchronously while transferring the signals from one end to another, from sender to receiver. So here all the systems in the clock, all the clocks in the systems are locked to the master clock, so which contains a fiber optic equipments. So here there is a bit weight is commonly, the Sonet is commonly transmits the data. The speed of the transmission of the data in the Sonet is between 155 megabytes per second and 2.5 gigabytes per second. And the most interesting characteristics of Sonet is that it supports a ring topology. So that is the most important characteristics of Sonet. Okay. So next we will go for Sonet layers. So Sonet layers is nothing but it has a 4 types of layers, which means path layer, line layer, section layer and photonic layer. So by seeing the diagram itself, we can know that path, line and section, these three comes under data link, and the photonic layer alone comes under physical layer. Okay, so we'll see what these 4 layers represents in the Sonet. So path layer now is responsible for the movement of a signals from its optical source to its destination. So it is from the source to destination, whatever the movement of a signal is there, it is responsible to the path signal. So just we will know what is each layer, and the next slide I'll show you the architecture of the Sonet. In that you can know how these layers are used in the Sonet architecture by using the Sonet devices. Okay. So line layer now, it is used for the signal across a physical line. So it is used for a movement of a signal across a physical line. Then section layer now, it is used across a physical section, handling framing, scrambling or error control. Again, photonic layer now, it corresponds to the physical layer of OSI model. So it corresponds to the layer of a OSI model. Next we'll go for a Sonet architecture. So this is the architecture of Sonet, which has ad hoc multiplexer, regenerator, then path termination, line termination, section termination and all those things. Okay. So by the diagram itself, we can know where the path layer is used, where the line layer is used and where the section layer is used. So the path layer is between the path termination and path termination, and the same thing, the line layer will be between the path and the line and the path, and all those things. So by looking at the diagram, you can know how this path layers are connected to the Sonet devices. Okay, so here in this architecture of the Sonet system, no, it has devices, we have connections, and we have the signals that are passing through the devices through some connections. So we are going to see what are those. Okay, so first we will see signals. So signals in Sonet. So this defines a hierarchy of an electrical signaling levels called as STS, which means synchronous transport signal. So the beginning itself, I have told that Sonet is it is a network that is used to transfer the signals synchronously. So that's why it is also called as synchronous transport signals. Corresponding to optical signals is called as optical carriers. So in terms of optical fiber, so by through optical fiber, they're transmitting some of the signals synchronously. So that is the meaning they have given here. Next, come to the devices. What are the devices used here is synchronous transport signal multiplexer or demultiplexer, regenerator, add drop multiplexer, and terminals. Here ADM is nothing but add or drop multiplexer. Sometimes the signals may drop to the, it will not come up to the level. Sometimes by adding some extra signals to the dropped signal, this will be used. Okay, so here the devices that are used here are STS multiplexer or demultiplexer, regenerator, add drop multiplexer, and terminal. Next, connections. As I said already, the Sonet line, path, line, and section layers are connected across the Sonet devices. So this is the architecture of Sonet. So after the architecture, the thing I want to tell is that Sonet is a synchronous transfer signal. As I told before, it is a synchronous transfer signal. It has more than 8,000 frames. So it has more than 8,000 frames to transfer the data. So that frames, now how it will be arranged? Now it will be arranged in two-dimensional matrix of bytes with 9 rows and 90 columns. So it will be arranged in two-dimensional matrix of rows, two-dimensional matrix of bytes with 9 rows by 90 columns. Okay, so this byte transmission, it will be from left to right and top to bottom. So just note it down, this one, it will be from left to right and top to bottom. So this is how the bytes will be transferred from one frame to another frame. So here 8,000 frames have been, I have told it has 8,000 frames, which means the Sonet signal is transmitting 8,000 frames per second is able to transmit 8,000 frames. So each byte in a Sonet frame can carry a digitized voice channel. So each byte, it can carry a digitized voice channel. So here the duration of any frame is 125 microseconds. In Sonet, the duration of transmitting these frames is 125 microseconds. So this is all about Sonet structure, architecture, and Sonet frames, how the data is transmitted from Sonet, how the Sonet is used to transmit the data through frames. Next, we are moving to Sonet networks. So Sonet networks, now it has three types of networks like linear network, ring network, and mesh network. So we are going to see what are these three types of network. So first we are going to linear network. So linear network, in the sense it is a point-to-point network. It has two types like point-to-point network and multiple point network. So you see, just see in a point-to-point network, it has one sender and one receiver. Okay, whereas in multi-point network, it has one sender and two receivers. Okay, so the only difference between the point-to-point network and multi-point network is that the add and drop multiplexer is used in a multi-point network, because we are sending multiple signals at a time. So when we are sending multiple signals of a time, synchronous transport system, after sending a signal to a synchronous transport system, then the signal regenerates. After regenerating, it goes to ADM, which means add or drop multiplexer. So that time a signal may drop, there will be a drop, which means it converts into DMX. Then after that, what happens, they're adding some extra signals to that, like extra electrical signals to that. Then after that, again it is degenerated and going to the receiver. This is what happens in the multi-point network. Just check it in a point-to-point network. Now just the sender is sending a signal to max, then it is regenerating, again regenerating, then the signal is converted to dmax, and then the receiver is receiving the message. So this is a linear network. So next we will go for ring network. So in ring network we are having two types, like UPSR and BLSR. UPSR is nothing but unidirectional path switching ring, and BLSR is nothing but bidirectional line switching ring. So we are going to see what is this. Okay, so first we will see what is bidirectional line switching ring. So bidirectional line switching ring is connected to two nodes. So one is production rings and another one is working rings. Okay, so it is connected to two nodes. When that node wants to send data to another node, so whenever a node wants to send data to another node, it sends the data to its left neighbor, when then forwards the data to left neighbor. So I'll repeat it. So it has this bidirectional line switching ring has two nodes, which means which sends the data both in clockwise and anti-clockwise direction by using both production and working rings. Okay, so here it is simple. This bidirectional line switching rings are simple to manage and simple to implement in the networks, especially while transmitting the data. They can be slower, but it is suitable for large networks with many nodes. So this is a bidirectional line switching ring. Next we'll go for unidirectional path switching. So unidirectional path, it has one sender and the receivers are three. So it has one sender. The sender sends a signal as one time but receives in the three places. Okay, so here the unidirectional path switching ring, it has two rings. One is working ring and another one is a protected ring. So you can see from the diagram, the working ring is a normal line and the protected ring is the dotted line. So in order to identify it, the diagram has been drawn like this. Okay, it is used to perform the path layer. So the node receives the two copies of electric signals at the path layer, compares them, then chooses one with a better quality. Okay, so when a signal fail condition is detected, the hardware initiates an interrupt to software which switches from working path to the production path or opposite way. So this is the process that happens in the unidirectional path switching ring. So this is all about Sonet ring network. So we have seen all those things. Now these are the advantages of Sonet. First one is reduced network. So this is the main advantage of Sonet is reduced network complexity, flexible topologies, efficient management of bandwidth, high data rate and production bandwidth. So the main disadvantages of Sonet is it is complex. The equipments that we are using and what are the Sonet devices we are using, it is very complex and costly. So strict synchronization schemes are required for Sonet transmitting signals. So these are the disadvantages of Sonet. Thank you.